Thank you very much for the call, and good morning from Spain. My name is Paul.
Thank you for that, Paul. I am just testing out a new vertical L antenna, and you are my first DX contact in about 30 years. So I am hugely chuffed. My QTH is Sydney, Australia. Okay. Cheers.
And there it is in all its glory.
Have it there, 30.2. So
Rubbing out all those horrible engineering equations.
okay, folks, been watching a heap of antenna videos, YouTube, gorging on YouTube videos, ham radio YouTube videos, and learning a lot along the way, having a great old time. And I was watching lots of videos by Peter Waters on the Waters and Stanton channel, so we'll give credit where credit is due. His call sign is G3, Golf 3, Oscar Juliet Victor. And he's done a whole heap of videos, and what's great about the videos that he does, of course, is that he runs a purveyor of equipment, antennas, transmitters, transceivers, whatnot, amateur radio gear, but he still encourages experimentation and the building of your own antennas, and I think that's an honourable thing to be doing, and shares a lot of information about construction of antennas, especially in suburban backyards and whatnot. Obviously that's probably a good thing in its own way, because it means more amateurs will be encouraged to buy HF gear, but he could be selling more antennas if he was just telling people to buy a store-bought one. So good on you, Peter Waters, for encouraging some experimentation. A couple of the antenna designs that he talked about he talked about a vertical L antenna, and also talked about a vertical antenna with a raised radial system, and he talks about the efficiency of having this system above the ground rather than on the ground, all that sort of stuff. So he does a lot of videos, so I will put links below to a number of those videos, but I would encourage you to go have a look at some of the videos that he presents. But the second antenna he did was a vertical with that radial system that was trapped at the top, trapped and loaded. So it was a full quarter wavelength for the 20 meter band, and then for 40 meters he produced a choke and a small length at the top to make it resonant on 40 meters on the 7 megahertz band. So that got me thinking, well, maybe I can do an L design, but with a tuned counterpoise, I guess we could call it, running along the roof. Now, you can look up L antennas. They are good at DX antennas if you can get them above the ground, and you get a nice low angle of radiation that's omnidirectional. So we are going to give it a crack. Now later on I could always add other radials to this vertical section and make it into a more conventional antenna. But at the moment, I've never tried a vertical L antenna, so it'll be nice to have an antenna that's for 20 meters, especially because the inverted V on 20 meters, I strongly suspect, is not that good an antenna. It's been good on 3.5 megs and on 7 megs, but on 20 meters, it's not a very good antenna. So I'm hoping to get some DX happening on 20 meters, fingers crossed, if the antenna works well. And I also thought, well, it'll be nice to have 40 meters in the bargain, and it'll be nice to be able to swap between the inverted V and the vertical and just see how my inverted V is performing compared to another antenna. It's always nice to have that second antenna to do that comparison. So stick with me, and this dream that's presently on the board is hopefully going to become a reality, and you'll get to see the whole process. So I guess I'm off to Bunnings and JCar, because I'm going to need some wire to wind some traps, and I'm going to need some antenna wire as well. So we'll get to it. Let's take 500. It helps if you hit start record. Okay, went to Bunnings and we got ourselves this cable. Now this cable is just off the reel. It's per meter. I think it was $1.60 something a meter. Probably too expensive, but hey, I wanted it. I bought it. It comes as actually a twin pair of cables joined together.
and I've just stripped them. And I'm assuming that this is going to be okay for outside because it's garden lighting, but you know, who knows. I've got myself a PVC pipe. I'm going to use this, I'm going to cut this up to make the coil former for the antenna. And I'm also going to cut a section of this and feed it through the wall, because I've been making the wall of the shack into Swiss cheese. And, you know, each time I want to put a cable through, I drill a hole. And, you know, I'm up to 3 at the moment, I think. So I'm thinking to myself, it'd probably be a smart move to put this through the wall, and then I can run lots of cables through it. And you just put a kitchen sponge around it and jam it in the hole to stop vermin from getting in the shack. Because the shack's a dirty enough place as it is without adding to the chaos. And we got ourselves some saddles, and I got a packet of saddles from, once again, Bunnings. And these are gas pipe saddles. And so they'll be good for outside. They won't rust and give up the ghost too soon. And of course, the ubiquitous electrical insulation tape, because you can never have too much of this tape and you're always losing the roll. So leave them lying all around the shack so you can find one when you need it. And last but not least, of course, the Haverford Squid pole, as advertised by Peter Parker, VK3YE, and I bought one of these for my antenna. I originally had a quite compromised antenna, which was a half wave at 40 meters with a trap for 80 meters. And I do a lot of operating on 80 meters. I don't know why. It's noisy. There's not many people down there. Most people can't put up an antenna that size. But for some reason, I just love 80 meters. Probably from my old novice days when I was a lad. So now I have a half wave end-fed antenna with a 49-to-1 unun that is at about 14 or 15 meters at the center, care of a squid pole that's 9 meters strapped to the chimney. So what we're going to do with this is, well, hey, I'll take it out and I'll show you what it looks like. I'm standing in a bloody puddle. This is the Haverford 6 meter squid pole. It was on special. I got on the Haverford side. I've already bought a 9 meter pole, which I've got strapped up there on the roof. So I went on the site trying to get another one. Unfortunately, they are sold out. But this was on special, and it's a 6 meter pole. And I'll just show you how high this is. Well, 6 meters doesn't seem like very high, but as you can see, it goes out to well, 6 meters, as you would well expect. It's a really nice and high pole, and the plan is to place it on this tower, wooden tower that I've built, and we're then going to have the tuned, it's going to be a vertical L, so we'll have one half of the antenna going up this pole and the other counterpoise, I guess you would call it, or the other half of the antenna going along the roof, elevated above the roof. And then we're going to have to play around with the length of that bit that's above the roof, because it may very well be required to shorten it to move the feed point because of the proximity to the roof and whatnot. So there'll be lots of experimenting going on. I'm very excited to get a vertical antenna going. I've never had a vertical antenna, and getting it above the ground means that I'll have a lower radiation angle, and hopefully I'll be able to get some DX on the log. That's what we're hoping for at any rate. The other thing is that once I've played around and lived with the antenna for a while, there's a very good chance I will also play around with the idea of elevated radials, or a set of radials, and using it as a quarter wave vertical in the more traditional sense. So that is the plan. Okay folks, we're back from JCar, and it's coffee time. We got ourselves some enameled wire, 1mm and 0.8mm, and we also got some wire to make radials. I will set this antenna up as a vertical L and see how it goes, and then later on we may make it into a more conventional Hertzian vertical with a radial system. And so we've got some wire to play around with radial elements, and it'll probably be elevated radials. After the coffee, we'll head off to the shack and we'll start winding some traps for the 2 legs of this vertical L antenna. I find a pair of clamps is your best friend. Why struggle? I'm going to cut these to about 7 centimeters, which is probably bigger than it needs to be, but better to have more room to move than less. And here's some holes to hold wire at either end, and I will put some smaller holes to actually wind the choke as well. And so we're going to have the wire twisting back and a little bit of strain relief happening, so that the strain happens on the actual piece of pipe rather than on the coil itself. And there you have it, 2 choke formers, 2 end insulators. Simple as that. 5 minutes. Now I know what you're probably thinking, why the hell doesn't he clean his desk up? Well, it's because that's the shambolic way I tend to work. So no point in fighting what you are. And I am a grub. Okay, point 8. This is the enamel wire that we got from J-Car. When we do our wire through here, we can create a strain relief between the coil and the actual winding. So we need about 30 turns. So it's an air wound coil. It's not going to be pretty. None of my coils ever are. But we just need to get it right. 2, 2, 3, 5, 9,
12, 13, 14, 15.
So now we're going to check to see what the magic number is on the LC meter. And we're hoping for around 30. So let's have a look. Got a bit of excess wire. It's not coiled, so it should make a huge amount of difference. Okay. At the moment, that's reading 35, so it's probably a little bit too high. So what we'll do is we will take a couple of windings off. So at the moment, we do have quite a bit of excess. Do another measure. Just under 34. So I would say we probably need to take a couple of turns off. So let's pull a couple of turns off this coil. Let's pop that in the hopefully we haven't taken too much off. Okay. Let's have a look now. No, we haven't got the insulation off yet. .4. So we said between 30 and 32 was where we wanted to be. So there you have it there, 30.2. So
I'm having a wonderful afternoon building antennas. It's cleared up, the rain has stopped, so I may even got to do the first test on this thing, and thinking about how I'm going to do the adjustments. So what I'm going to do is, where the trap is and the short part is, I'm going to solder and finish that off, get all that stuff done, and we are going to do the adjustments at the coax end. So basically at the center of the L, we're going to adjust there, and I'm going to use screw down connectors that I've got, electrical connectors, so that I can take a bit off the antenna, screw it down again, nano VNA it, continue on. You adjust the higher frequency first, the 14 megahertz 20 meter amateur band first, get that approximately correct for whatever section of the band that you want to be using, and then you adjust the stub. And the stub adjustment at the end is very, it's quite a narrow tune, and you have to take off very small amounts. So also I've been told, I'm going to find all of that out shortly. And recent purchase, I bought myself a higher power soldering iron, because I was trying to do balun connections with thick enameled wire and whatnot, and it was an absolute disaster. So that's going to improve things immensely. Another thing with this antenna, I've been told, is it should have a common mode current choke on it to make it behave itself. I have ordered the toroids required for that, and I will do a quick video on that, even though it's been done to death. Can't hurt. That video will happen when the actual toroid arrives, but I can test it low power, and I certainly can test it on the VNA and get it all adjusted. But I probably will try and do a quick lower power QSO just in case some RF does arrive in the shack. But thus far, because I operate quite low power, we haven't had any issues with RF in the shack with the end fed, and I'm not imagining it's going to be a problem for me anytime soon. Okay, so what I'm doing is I'm just soldering the coil loading / choke coil that allows this antenna to operate down on the 7 megahertz 40 meter band. This is a terrible stand. And that's fixed it. But I will show you what I've done. I've soldered the wire to the core so that when this is up, the strain is not on the coil. And this bit here is just taped at the moment, but I'll cable tie that as well, and tape up this this soldered joint, and also tape the whole assembly so that it's, you know, reasonably weatherproof. And at this end here, when I do adjust the 40 meter frequency, this is the bit that I'll be shortening or lengthening. Okay, so that is the process. It'll happen on both legs of the antenna. Anyway, I will get this all taped up, and won't bore you with all those details, and I'll show you it at the end. Okay, so that's your choke / trap, and yes, I have gone to town with the masking tape. And up here I've got a cable tie, which I've also wrapped just to make it live a little bit longer in the UV. Obviously the tape's going to fail as well, but you know,
we might get a little bit longer life out of it if we make it a little bit more weatherproof. Yeah, so that's my choke slash trap, and that goes up to the top of the antenna like I said. And now I just have to reproduce that on the other leg with an insulator. We've got our center done already. We'll be doing our adjustments of length here at the center by removing this tape and just shortening or lengthening it to get the nano VNA to tell us what we want to hear. We'll have these in terminal blocks so we can unscrew and re-terminate very easily rather than soldering. So all these connections are now permanent, and now all I need to do is put the other trap on, and we're ready to hoist the mainsail.
And there it is in all its glory. Let's pop up on the roof and have a look at what the Nano VNA is doing. I have happy tales to tell. Okay. We've got an SWR of about 1.2. Getting a low battery warning, just what we need. Let's have a look here. So 14.010. 1.16 is to 1. The 7 megs. We have an SWR of 1.41 is to 1. Narrower as expected because it's trapped. That's at 7.260, so a bit high for me. So I'll be shortening the stubs on this to get it to behave. I'll be doing that tomorrow because I've got to go out to dinner tonight. I am just very, very pleased. I'll just jump on the roof and show you a little bit more of the installation. Trying not to fall off the roof or step on the Nano VNA. We've got a temporary support over there. Our loaded counterpoise. And, well, this is where we're going to be shortening if we need to shorten or lengthen the this 14 meg section, but I don't think we will have to do that. We will have to probably adjust the stub. But yeah, happy days.
So rather than run a million cables through the wall, I've hacked my way through the wall here, and we're going to run this piece of PVC pipe through the wall just here, and that'll allow me to run, you know, 8 or 9 cables through here. I'm sure I'm not going to need that many, fingers crossed. So now we've got a magic portal to the outside world, and we'll just wrap the cable in a dish sponge when we push it in the wall, stop the greeblies from getting in. We've also put a bit of fixative on it to hold it in the wall.
Well, that's an incentive if ever I saw one. Okay, so we're looking at the antenna and how it performs from 6 to 8 megs, and I really wanted to get this 7 meg section of the antenna reliable. It's resonant at 7.060 with an SWR as 1 is to 1.16. If we go to the bottom of the band at 7 megahertz flat, we're at 1 is to 1.7, so it's still a very usable SWR below 2, and we start climbing up to an SWR of around 2. That's 1 is to 1.91 at 7.120, and when we get to 7.140 we've got 2 is to 2.29, so I probably wouldn't want to go much over 7.120, but that's 120 kilohertz of the 7 megahertz band, mostly the bottom end, which is where I want to hang out doing a CW. So that is how it's performing on the 40 meter band. I'll pop it over to the 14 megahertz 20 meter band, and then I'll open that can of beer and get it in me, some of that Cooper's South Australian beer. And we just did a recalibrate on the Nano VNA, and that is our response for 13 to 15 megs. So starting at, let's get it up to the start. So at 13 megs, it's at 1 is to 2.98. We don't get down below 2 till okay. So we're at 13.5. So we could probably move the tuning for this, but at any rate, let's get to 14 megs and see what it is at 14. It actually goes up slower than it comes down, so it's probably a good deal that it's resonant going in the other direction, if you get my drift, which you probably don't. So 1 is to 1.15 at 14 megahertz. Best SWR is at 14.060 at 1 is to 1.08. And then we climb back out again. I think we can go right outside the band. We're at 14.4, 14.5, and we're still below 2. And as we climb up to 15, 14.82, we're still below 2. We don't hit 2 until we get to 14.8, which is outside the amateur band. So this is a great SWR for 14 megahertz. I can basically plug anything into this antenna on the 20 meter band and be confident that it's going to behave itself. Okay. Cheers. Woohoo! So that is a Tasmanian station talking to a West Australian station. And I've had my, as you saw at the beginning of the video, my first confirmed kill for DX, and it was Echo Alpha 5 Juliet Zulu, Paul in Spain. And on the 40 meter section of the antenna, I've had 2 CW QSOs, one in Walsha and one in Adelaide, Victor Kilo 5 Golf, I think it was, Graham. So I was running 5 watts for that QSO, so it's working well on 40 meters and 20 meters. Now my inverted V, when I swap between the two, certainly on 20 meters, I'm noticing at least half an S point improvement on receive, and it just seems to be a cleaner signal, surprisingly. But yeah, it's working really, really well. It's nice to have that comparison between the two antennas, and of course the inverted V doesn't load up very well on 20 meters. I have to use an antenna tuner, and my antenna tuner is a QRP antenna tuner. So I'm not really keen on putting more than, say, 20 watts through it, although I have run it up to 50 and it seems to be all right. I don't want to tempt fate and have the capacitor arc over. So that is the antenna. So if you've watched this point, thank you so much. Hope you've enjoyed it. And if you have any questions, comment below. I'm happy to answer any questions about the antenna and the tribulations of its creation and installation. So what's coming up in future videos? Well, we've had some wonderful things arrive in the mail from mini kits, and I've been waiting for parts so that I can make my mooncake transmitter here, which presently is QRPP. It's only about 450 milliwatts. So we're going to make that into probably a couple of watts, maybe 3 if we're lucky, with an IRF 510 and a new low pass filter as well to make sure we're not putting out any spurious emissions. So that's all in here, along with a few other little goodies that I couldn't resist. And even more exciting news, it took a little while because they sold out very, very quickly, but this is the QRP Labs QDX data transceiver. It's about the size of a packet of cigarettes, and it plugs into your computer, and it's a complete digital modes transceiver. So I am so excited about dipping my toe into the world of digital communications. So we've gone from very old school QRPP transmitter receiver combos to state-of-the-art communications. And this is a kit,
and I'll be showing you. I won't be showing the construction of this. There's 1,000 people that have done that, but I will show you what's inside the box later on, and we'll get it built, and I'll let you know how I go with my digital communications. Anyway, 73s from VK2 AOE, and we will see you in the next video.